Now we are going to do exercise 1 from the central limit theorem and sample theory set of problems. It says, if you launch a regular coin 500 times, calculate the probability of obtaining A at least 270 heads. So, when we are launching a coin, it is a Bernoulli experiment. That means we can get a success or a fail. So we will call our success to get a head. So, and we will call it xi. So, as we said, it follows a Bernoulli distribution with a probability of 1/2. As the experiment is repeated 500 times, we will use the Moivre-Laplace theorem. So we will call this the total number of heads. So we are going to use the Moivre-Laplace theorem that says that when n is enough big, the variables of the succession tends to a normal distribution 0, 1 when applying this formula. So we are asked to calculate that the probability that at least we obtain 270 heads. So we can see here how we have expressed, but when we are calculating that, we usually do the other way around. That's it. 1 minus probability that the succession of t is smaller than 270. Now we will use the Moivre-Laplace theorem. Take a look, we have followed all the steps, and now we just have to look for this value in the normal distribution table. So we get that this is equal to 1 minus 0.96327. And when doing the calculus, we get that this is equal to 0.03673. So this is the final result of part A. Let's continue with part B, where we have to calculate the probability of obtaining between 240 and 260 heads. That is writing like this. Applying the properties of the distribution, we can see graphically that the probability we are asked will correspond with this green area. So in order to calculate the probability, we are going to make it in two parts. So this one and this other one. So now we are going to use the Moivre-Laplace theorem. The first step has been converted them into a normal distribution. Now we are going to simplify the expressions. As we get a negative result, we are going to change the sign of the probability. Now the following step is simplifying this expression as much as possible. take a look. Here we have the sign on the contrary way, so we have changed there, and we have take common factor here. So now we just have to look this probability in the normal distribution table. Following the calculus, we get that this is equal to 0.6266. So we have get our final result of part B. This video was recorded by María José López Martínez in the academic year 2012-2013. Thank you for watching.